Okay, let's look at our first situation. Zark is buying peanuts and cashews for a party. He can spend no more than $12. Peanuts cost $2 per pound and cashews cost $4 per pound. So in this problem, we're going to let X represent the number of pounds of peanuts, and we're going to let Y represent the number of pounds of cashews. So the first thing I want to look at is a total. If you can spend no more than $12, then that means you can spend $12 or less. So we're going to use a less than or equal to. Has to be a less than or equal to because all you have is $12. So if what you're spending is going to cost more than $12, then you're over budget. So less than or equal to $12. Okay, so now let's look at the other numbers that goes along in this problem. So $2 for cashews, $2 for peanuts. Peanuts we're going to use as X. So $2 times your pounds of times your pounds of peanuts, and then $4 for cashews. So 4Y. So now we have our inequality, and we're going to graph this. So to find my x-intercept, remember that's where I'm on the x-axis at. And so if I'm sitting on the x-axis, I have a y value of 0. If I plug 0 into y, then that term basically goes away because 4 times 0 is 0. So 2x is equal to 12. Divide 12 by 2, so I have an x-intercept at 6, or 6, 0. So I'm going to graph that point. Also, don't forget to label your x and y axis. So this is pounds of peanuts. And so now we're going to find our y-intercept. So for my y-intercept, that's when I'm sitting on the y-axis, which means I have an x value of 0. If I plug 0 into x, that term goes away. So 4y equals 12. Divide 12 by 4, and I have a y-intercept of 3. And so my y-axis is pounds of cashews. Okay. Now, what type of line does it have to be? Well, because it's a less than or equal to, it's going to be a solid line, which means anything that falls on that line is part of the solution. And then now, how are we going to shade? Well, we're less than or equal to, so we want to make sure that we shade below the line. So if I only have one inequality graphed, why is this a systems? Where do the other inequalities come from? Well, notice what coordinate plane I'm using. Notice how I'm only using the positive quadrant. Well, the reason why is because there's no way I can have a negative amount of pounds for cashews and a negative amount of pounds for peanuts. So my pounds has to be 0 or more, which is why I'm working in the positive quadrant. So now, which ones of these solutions falls into the equation, or which one's going to be part of the solution? So what I want to do is I want to check. I'm going to go and look. Is 2, 4 a solution? No. Do you see how it's outside of the shaded region? So 2, 4 is not a solution. Is 4, 0 a solution? 0 falls here. So yes, it is in the shaded region. So yes, it is a solution. What about 3, 1? 3, 1 appears to be a solution. If I drew my line straight, it looks like it's definitely a solution, but let's check it and see. So 3 is an X and 1 is a Y. If I take that point and I plug it back in, is 2 times 3 plus 4 times 1 less than or equal to 12? 2 times 3 is 6. 4 times 1 is 4. 6 plus 4 is 10. So yes, 10 is less than or equal to 12. So yes, that one is also a solution. Now, let's answer the next question. So what is the greatest number of pounds of peanuts that Zark can buy? So if you look at the shaded region, the greatest pounds of peanuts, well, looks like he can buy 1 pound. He could buy 1.5 pounds. He can buy 0 pounds. He could buy 0.5 pounds. So what's going to be the greatest amount? Well, if I look, it appears to be 6. 6 is the greatest amount of peanuts that he can buy. Because if he buys 7, you see how we're outside of the shaded region? So if you're not sure, plug it in. So if I take, and I go back to my equation, if I plug 6 into my X, which means Y is going to be 0. 2 times 6 is 12. 4 times 0 is 0. 12 is equal to 12. So what is the greatest number of pounds of peanuts that Zark can buy? 6 pounds. And then the last question. If X is 3 pounds, what are all possible values of Y? So just like we did before, we're going to take 3 and we're going to sub it into X. Two times 3 is 6. 6 plus 4y is less than or equal to 12. Well, do you see how we've got an inequality that we can solve? Subtract 6 from 12, and you get 4y is less than or equal to 6. And then divide both sides by 4. 6 divided by 4 is 1.5. So what are all possible values of y? Well, anything less than or equal to 1.5, but we can't go into the negative. So y has to fall between 0 and 1.5. So he can buy greater than or equal to 0 or less than or equal to 1.5. Okay, so there's our first example we've done together. Situation 2, rub-a-dub-dub. Try it on your own and see how you do on this one.